Hello everyone, let's look at Leetcode question 1762, Buildings with an Ocean View. At time of recording, this question has 1.1 thousand upvotes and 144 downvotes. The question is, there are n buildings in a line. You are given an integer array heights of size n that represents the heights of the buildings in a line, and the ocean is to the right of all the buildings. So a building has an ocean view if the building can see the ocean without obstructions from the other buildings. So a building has an ocean view if all the buildings to the right have smaller height. Return the list of index values of each building that has an ocean view, sorted in increasing order. Okay, so here are the different heights for each input example. Let's look at the constraints, then the examples in depth. So the heights.length array input list will be between 1 and 100,000 buildings in a line. And the height of each building will be between 1 and a billion. So there might be some skyscrapers. Okay, running through the code, what we first do is define a stack. This will keep track of all the building heights in the stack. Then we create a for loop and define the index I in the height of the building. And to do this, we have to enumerate every height. So then we have an inner while loop that checks if the stack exists, which will check then if there are buildings in the stack, and then it'll check the height of the previous building by doing height stack -1. If the previous building height is less than or equal to the current height, that means this building will not have a view to the ocean, so we have to pop it out of the stack. And since it's a while loop, we will keep on checking the previous buildings that are smaller or equal to the current building height, because all of these buildings will not be able to have an ocean view. And once we exit this while loop, we can append to the stack the buildings that do have an ocean view, and then iterate through every single building, and finally return the stack of all the buildings' indices that can see the ocean. Okay, let's go through the first example. So we first define a stack. This will represent our stack right here. And we go through the for I height and enumerate heights loop. So the I is the index of each building height, and the first one is going to be 4. Okay, so while stack exists, currently there's nothing in stack, so this while loop can be ignored. We simply stack.append I. I is the index value of the height, so height is 4 and index is currently at 0. So we append the 0 index for the height value, and then we iterate then to the next height value of 2, and then we check while stack exists, it does exist, and heights stack at -1 is less than or equal to height. So heights at stack -1 is 0, and 0 is the index value, so heights at 0 is 4. Is 4 less than or equal to height, which is 2 currently? No, 4 is not less than or equal to 2, so we don't need to pop anything from the stack, and we can simply append the index value for height 2, and the index value for height 2 is 1. So far the stack looks like this, 1 and 0 on the bottom. Now we iterate once more to the next height in our list of heights, and it's at I index 2 now, and we check while stack exists, yes, there is something in stack, and heights at stack -1. So heights at stack -1 is the index value of 1, and that's a height of 2. And 2 is less than or equal to 3. This is actually true, so we pop off this stack right here. So we pop off this 1. So now the stack is just 0. And since the while loop is continuous, we do the same thing and check while stack and heights at 0. So 4 less than or equal to 3. No, we don't need to pop out the index 0 because 4 is not less than or equal to 3. And then we exit this while loop then and append the stack 3, which is at index 2. Okay, and then finally we have the last iteration of the height. It's at index 3, and it's the height of 1. And we check while stack exists, yes it does, and heights at stack -1, which is 2, and heights at 2 is 3. Is 3 less than or equal to height of 1? No, it's not, so we don't pop anything out of the stack, and we simply append then the final height index, which is stack.append index 3. And then we can finally exit this while loop, or not the while loop, the for loop, because we've iterated through every single height and return the stack. So the stack is 0, 2, 3. Okay, let's try this example now. The heights are of 4, 3, 2, and 1. So we create our empty stack and we iterate the for loop I, height, and enumerate heights. So I is the index of all the heights. Currently it is index 0 and the height is 4. And we check while stack. No, there's nothing in stack. So we exit this while loop, append simply the index 0. Next we iterate to the 3. It's just getting smaller and smaller, so you can imagine what's going to happen. So I, while stack, and heights at 1, which is, or stacks -1, 4, is 4 less than or equal to current height? 3? No, so we don't pop anything. Append index 1. Now we go to index 2 now. While stack, heights at -1, less than or equal to height. Nope, 3 is not less than or equal to 2. Simply append. And then finally we have the index of 3 and height of 1. Check the stack. Is 2 less than or equal to 1? Nope. Append index final value 3. So output is 0, 1, 2, 3. Here is the final example. We have heights of 1, 3, 2, 4. So which buildings will be able to see the ocean? Let's iterate through the example once more. So stack is an empty one. And for I, height, enumerate heights. The first is index 0, height 1. Stack doesn't exist. We can simply add the index of height 1, which is 0. Next is for height and enumerate 3. So index 1, height 3. While stack exists and height at 0, 1 is less than or equal to height at 3, which is actually true. So we have to remove this one index. We pop it off and append index 1. This makes sense because clearly this building can't see the ocean because 3 is blocking it, and so is 2 and 4. Okay, so then we go to the next one, and it's 2 now. For I, height, enumerate heights, so index 2, height 2. While stack exists, yep, and stack 3, is that less than or equal to 2? No, we don't pop it out. 3 can still see over 2. Append 2. And then the final height for I, height, index 3, height 4. While stack exists, yes, and heights at -1, stack -1 is 2. Is 2 less than or equal to 4? Yes, so we pop off 2. And the while loop repeats itself again, and we check, okay, stack exists? Yes, there is one value left. So at heights -1, which is just this one value here, is that less than or equal to height? So stack at -1 is the topmost value of the stack, and that is 3. Heights of stack -3. -1, I mean, is 3. 3 is less than or equal to 4. Simply add the 4 then, and we can exit, and we return just, or not 4, 3, sorry. 3, the index of the stack, not the height, so we return 3. Okay, let's check the solution. Let's check it out. Okay, great. It works. So what is the time complexity of this solution? The time complexity is O of n, where n is the length of the input list heights. This is because we iterate through the list once to find the building's heights of every single building. The space complexity is O of k, where k is the number of buildings that can see the ocean, see the sunset. In the worst case, all buildings can see the sunset, so the stack will contain all the buildings. And that's the space complexity. That's it for this question. Thank you for watching.